we go. Okay. Welcome, everyone, to our Friday Transportation Seminar. My name is Jennifer Dill. I'm a faculty member here in Urban Studies and Planning and director of OTREC, and we help co-organize this seminar along with my colleagues, Miguel Figliozzi in Civil and Environmental Engineering, who will be arriving shortly. I think this might be a good day to do some quick introductions around the room so that we have an idea of our audience. And this is also a good time to remind everyone and to tell the people who might be new to our seminar is that we do webcast the seminar. And so the people watching on the web, and there are always a few out there, in order for them to hear what we say in this room, you need to be using the microphones that are on each desk, most desks I should say. When you're asking a question or when you're introducing yourself, touch the touch button, keep the red light lit while you are speaking so the people watching on the web, both live and archived, can hear you. So let's do some quick introductions. We're going to go this side of the room first, then over here. Just your name and affiliation, because I know we have some people who have joined us from further afar. So let's start over here.
I'm Katie Bell, Transportation Engineering at PSU.
Kate Hunter-Zaworski, Transportation Professor at Oregon State University.
Carlos Gonzalez, I'm a Transportation Certificate Program.
Chris Monsier, Civil and Environmental Engineering at Portland State.
Justin Carinci, OTREC Communications.
John Mackler, OTREC.
Give you this.
Thank you. Christopher Weird, City of Portland.
Jason Labrado, postback.
Ashley Harris, Urban Planning graduate student at PSU.
Erica Smith, Urban Graduate Planning student.
Jeremy Grotbo, architecture student, prospective MERP student.
Shubin Najafi, transportation student at PSU.
Yasna Koloshinas, transportation student at PSU.
Melissa Rosskamp, graduate student in environmental engineering.
Desk if you want.
Mark Person, Masters of Urban Regional Planning student here at Portland State.
I'm Katie Perko. I'm an undergrad in the Urban Planning School.
Patrick Leese. I'm a civil engineering student here at PSU.
Kirk Paulson, graduate student in transportation here at PSU.
Okay. So thank you, everyone. So without further ado, I'm going to introduce our speaker, Brock Nelson, who is with Union Pacific Railroad. Brock has over 35 years of management experience in the railroad industry. He's a graduate of Iowa State University with a BS in civil engineering. I understand Go Cyclones is in order. He began his railroad career with the Chicago and Northwestern Railroad in 1976, where he held numerous positions in the engineering department. Brock's railroad career also includes 16 years managing environmental compliance programs in various capacities. He's currently the Director of Public Affairs for the states of Oregon and Washington and is headquartered here in Portland. Take it away.
Well, thank you very much. Appreciate you affording me the opportunity to talk to you today. Hopefully I've got some things that you'll find of interest. Union Pacific has been operating a railroad now for 150 years. Matter of fact, this year is our 150th anniversary, and for those of you that have an interest, we're going to have quite an event at Union Station on July 13th and 14th this summer. We're going to bring some of our heritage equipment out and put it on display for the public, and it'll be really cool. So we've been dealing with Mother Nature and the environment for quite some time, and I'm going to give you some examples this afternoon of some of the challenges we've been presented with. But I think I'll start out by just kind of giving you a little bit of an overview about the company, who we are, where we are. And feel free to ask questions. I've spent time in my career in our track department, maintaining and building track. I've been in our bridge department, building and maintaining bridges. I've done facility work, intermodal facilities, diesel shops, things of that nature, and then 16 years of environmental compliance on several of the regions on the railroad. So I'd like to say I know a little about a lot of things, so hopefully I can answer any questions you might have. All right, this is Union Pacific Railroad. We're the largest Class 1 railroad in North America. We operate in 23 states, pretty much all west of the Mississippi. We interchange with the eastern railroads in Chicago, St. Louis, Memphis, and New Orleans. And we've got 6 crossings into Mexico where we interchange down there, and then we go into Canada up in Eastport, Idaho. So 32,000 miles of rail, 40-some-odd thousand employees, like 8,000 locomotives, and we go through 7,000 communities. So being a good neighbor and learning how to get along, we know all about that kind of stuff. So now this is just a little snapshot. It's not a real robust map of where we are in the state of Oregon. We have about 1,500 employees and just a little over 1,000 miles of railroad in the state. Come from down south. Klamath Falls is on the southern part of the state, and then Ontario, Oregon out in the east, and then we'd cross over into Vancouver across the Columbia River. And going north out of here, we operate over the Burlington Northern Railroad. Railroads can have operating rights over each other. You know, the equipment's all interchangeable. So to maintain competition, there's times that we'll operate over them, they'll operate over us. And it also comes in handy in the event that you've got an emergency situation and need a detour, and I'm going to show you some examples of that here in a little bit. Now, railroads measure their health in car loadings. And these are 7-day averages for car loadings. You can kind of see that things kind of went down back in 2008 as the economy declined. And at rock bottom, we were down around 152,000 car loads weekly. And actually, we started to feel the impending economic downturn before it happened. And if you think about it, we're providing materials for a lot of the industries that felt the crunch. And as those industries started to have their challenges, our car loading started to decline. Warren Buffett was interviewed one time on CNN and was asked what's the best indicator of the economy, and he said railroad car loadings. So you could see it coming, and the good news is now we're updating our charts to get our 2011 numbers in there, but we got back up to 172,000 car loads in 2010, and we ended last year in the high 170s, 180,000 range. So it's come back, but it's like it's not sure what it really wants to do. You know, whether the economy wants to take off and go, or whether we're just going to kind of sit here for a while. But for our railroad, given our current capacity, 200,000 cars on a weekly basis is a pretty good number for us. You know, as long as and we can handle a little more than that as long as everything's running fluid. But once you start to get you have a problem someplace, it's just like a domino. It'll start causing congestion, and it can just spread across the system. Now, the railroad industry is, you know, I say one of the most, but I think I'm safe in saying it is the most capital-intensive industry by far. We own our own infrastructure. We maintain our own infrastructure. We spend 17% on average for the industry in maintaining and growing the business. So it is very, very capital-intensive. You see next to railroads, utilities are the next biggest industry with capital needs. So it takes money to be able to run the railroad. Now, the future is bright for rail. Actually, for many years, I think folks probably didn't even recognize that we were around. When gas started going up, diesel started going up, there was a renewed interest in freight rail transportation, and we are a very good mode of transportation, and the demand for freight rail is going to double here in the next well, between now and 2035. I think they're projecting that, and so the challenge again, being that we are so capital intensive, is how are we going to meet that demand going forward? As we continue to grow our revenue, we continue to put more money back into the infrastructure, because it takes time to build railroad and capital, of course, to do it. So we've got a real challenge here going forward to be able to meet this demand. Now this eye chart, I call it, is just kind of what we just talked about, how that's going to translate into the rail network in the future. And you can see on the left-hand side, basically green is good. That's the whole, that's not just UP's network, that's the whole rail network. And those are, green is where there's capacity as it exists today. Based on the growing demand, red is a challenge. And the challenge is how we're going to have the revenue and the money to be able to get out there and expand the capacity to deal with that. We are, if not the, but one of the most environmentally friendly modes of transportation. We have the UP as the greenest fleet of locomotives in North America. We can move 1 ton over 500 miles on a gallon of diesel fuel. And if you were to take 10% of existing truck traffic and put it on the rail, you would save somewhere around 1 billion gallons of diesel fuel annually. So it's a very green mode of transportation, and we're doing things technologically to become even greener yet. We are nip and tuck with the U.S. Navy when it comes to consuming diesel fuel. We are very motivated to reduce our carbon footprint, trust me, to keep our consumption down, because it's a big part of what our resources are to run our railroad. This is just a comparison between freight rail transportation and trucks. This by no means is an advertisement saying that we can do away with trucks. We need trucks. Trucks are one of our partners. We can't get that last mile from point of origin or to a point of origin or point of destination. So they're a partner of ours, but we are more fuel efficient than trucks. And as we go forward, as a society challenged with the failing infrastructure, you got to think about freight rail transportation. One of our intermodal trains can take 300 trucks off the highway. And so that relieves congestion, takes stress off the system. So we can be part of the solution going forward here as we face that challenge. Now I've just kind of inserted this slide because I actually think it's just kind of cool. We were talking about how we can operate over different railroads, all the equipment and the locomotives is interchangeable. This is where one locomotive traveled in 60 days. So whereas it can be here in Portland this week, it can make it all the way to the East Coast by interchanging with one of the eastern roads, and they just go back and forth. There's a very complex accounting system that I couldn't even begin to explain, but while our locomotives on their railroad, we're paying them, while their locomotives on our railroad, they're paying us, and there's this big system of checks and balances that has been working for decades, if not a century, but I couldn't begin to explain how it all happens. But the equipment and the trains can go operate on the different railroads across the country. All right, now this is what the meat of what we want to talk about today is, and when John first contacted me, he said, well, we want to hear about some of the day-to-day challenges the railroad industry has, the day-to-day emergencies that we face. again, being in existence for 150 years, dealing with Mother Nature is just a part of our business. It's not a lot of rocket science, into what we do when we're faced with these challenges. But I think I've got some pretty cool things to show you here, and I'm going to lead off with this. And my CEO, and I love this statement, he calls Union Pacific Railroad a 32,000-mile factory without a roof. And so let's start off with this, and I hope my clip works.
This is KCRA 3 reports at 6 in high definition, where the news comes first. Now to clearing the tracks. Right now, Union Pacific is plowing a lot of snow to make sure that the route through the Sierra is safe to travel.
Check out this piece of equipment here. KCRA 3's Dan Shively is in Live Copter 3 HD over the scene near Nyack, and they are still pushing lots of snow there, Dan.
Boy, it is a very impressive sight, and I could go on about how awesome it looks, but I've got an expert on the phone right now, Aaron Hunt from UP. Hi, Aaron. Thanks for joining us. What can you tell us about this magnificent machine?
You know, this is one of our rotary snow plows that have been around for decades and decades on the railroad, and we're putting it to work up there over Donner Summit.
Boy, now this doesn't happen every year. Is that correct? We don't see this come out every year?
You know, this is a really special piece of equipment. We keep them maintained, but it's been 13 years since we've had these operating out over Donner. We keep them stored in our J.R. Davis yard in Roseville and ready to go, and we've had so much snow. There's over 560 inches of snow on the summit this year, and that's about 150 inches above average. 13 feet of snow in the last 7 days, so we had to put these things to work to try and get that line back open and get commerce flowing again.
Boy, it's a very impressive sight. You know, we did actually see it get clogged up, and the operators had to get out and clear some snow. So it's not just all that horsepower, it's some manpower as well.
You know, the crew that works on these with this equipment, they're a special group. We've had a team of 100 folks up on the mountain working for over 5 days to clear those tracks. And this piece of equipment is real special to us, and we're real proud of it. We keep these things maintained. They've been around since 1950, and some even from the late 30s. So, yeah, occasionally they do have to step out and scrape some of that snow off the front of that rotary plow that's about 16 feet tall.
Wow, impressive. Aaron Hunt of Union Pacific, thanks so much for joining us and giving us some more information. It is just incredible up here. Back to you, Gulston and Edie.
It is just such a beautiful picture.
It's cool.
It is cool.
You can't get them at Home Depot, though.
I love that
line. To the UP yard there.
I'm very sorry about that, Gulston.
I'll be okay.
A lot of folks want one of those tonight. Well, you can ski and snow.
Okay, that was last year. That we experienced that. Let's see here. There we go. Of course, Donner Summit is where got its name from, where the travelers, the pioneers, got stranded. And back, I don't know what year that was, but we get just a horrific amount of snow up there. And again, it's just something we have to deal with. And we're typically able to manage it with pieces of equipment much smaller than that rotary plow, but pretty impressive nonetheless. And I've kept that video and showed it many times. So, well, we're going to go back. I can safely say, I wasn't around when this occurred, but it did. The San Francisco earthquake did create a lot of challenges, not only for the public and the railroad, but the story that's told about this is not so much the damage that it created to the railroad, but what the railroad did for hauling in supplies to the area over a long period of time as they rebuilt and people recovered from this horrific earthquake. Just another picture. There's some tracks in the foreground, and you'll see, as we go forward and look at some of these examples, track is pretty forgiving, when it comes to what the environment and Mother Nature can do to it. And you'll see some pretty cool examples of how it can bend and twist, and it's all about There's engineers and experts in here. It's just all about transferring the load from the rail through the tie plate, through the tie into the ballast, and we just need something good to support our track on to be able to do that. This was another, so it almost seems like between 1909 and the earthquake that nothing really happened of significance, but I couldn't find anything in the archives until I got to 1949, and this blizzard. This was back in the Midwest, so this would be Nebraska, Iowa, that neck of the woods. Apparently, this continued for like 7 weeks, and just literally froze the railroad down. Now, and you'll see we're still running steam under that block of ice. There is a steam engine. So we didn't convert to diesel electrics until probably the early 50s. But freezing temperatures and blowing snow, it's all a challenge for us. Now we're getting a little bit closer to more modern times. I actually experienced this series of pictures. This is, I think, 1992 or 93 when we had and I was working back in the Midwest at the time, where we had the snow melt and rain in the Midwest, and the Mississippi and the Missouri got out of their banks. And we had 1,700 miles either underwater or impacted by that flooding. And in most cases, all you can do is wait for the water to recede. There's really just nothing you can do. Now, I had just gotten into the environmental department about this time, and I had never seen this challenge coming, but with water and floods comes floating debris. And when the water recedes, whatever's on your property is your responsibility. I ended up cleaning up a variety of drums and tanks and things that just happened to end up on my property. So I had never seen that one coming at the time, but when things get up and move in floodwaters, they eventually settle in someplace, and as a landowner, you need to deal with it. This is down around St. Louis, where the Mississippi and the Missouri come together, and 4 miles wide in this area, and you can just see this little string or stream through the middle there is the railroad track. And again, there's just nothing you're going to be able to do until that water recedes. Now, we can, under circumstances where there's not a lot of flow, eroding away your embankment or your subgrade, we can go through water when it's over the tracks, but not very much of it, because a locomotive, it's a diesel electric locomotive, so the actual internal combustion engine runs a generator that provides electricity to the traction motors. So if the traction motors get wet, they don't work. So you can accommodate a couple inches of water over the track, but if it starts to scour and to run to where you don't know what you got underneath you, we're out of business. I experienced these firsthand. I was in our environmental department and worked with the regulatory agencies to make the notifications for these situations, and worked with the different departments to get the operations restored. This was a storm that came in off the ocean and just pounded. This is our Santa Barbara sub, so this is down between San Francisco and LA on the coastline. Just hammered us. I can't remember how many miles we lost here, but this storm continued to go east and dumped 10, 12 inches of snow in southwestern Nevada. A subsequent storm came through with warmer rain and melted all the snow. And I'm going to show you what that did. But this was a huge service interruption for us. This is out in the this is southwestern Nevada. It's called the Caliente Canyon. These cars were just standing in a siding, and the floodwaters eroded the subgrade right out from underneath it, and they just tipped over. Now, the good news, and you probably wonder yourself when these things tip over or they're near water, what happens to the commodity that's inside it? Well, railroad cars are pretty intact. Pretty secure. We did not have any commodities that got out of the package. These just kind of settled in and fell over on their side. But that is a concern when you've got water and you've got commodities that can come in contact with them. So the regulatory agencies really take an interest in stuff like this. These are more pictures of the same because they're just mind-boggling to me. And this is just runoff coming down the tracks on the left-hand side. We had one of our managers fly this in a helicopter because we couldn't get in by road to any of these locations. It's a very remote area. In total, there was 70 miles of track that was washed out. And it took us 6 months to put this back in service. And again, back to my comment about being able to detour and have some redundancy. The good news is our shippers experienced some minor delays, but we've got ways to get around this stuff, and that's a good thing. More of the same, you can just see the river got out of its bank, just scoured out from underneath the track and just laid it over on its side. This one, I think it was the first time since I'd been in college that I'd actually said alluvial fan before. And this was a stream coming down, joining another stream, and this sediment just came out and just basically buried everything down at the outfall of the one stream. The challenge here for us when we were putting this back is that the rivers had changed their course, and actually, when it comes to restoring something like this from a regulatory perspective, you put it back the way it was. You put it back the way it was. So you can't change it. So if you need to do something other than put it back the way it was, you're going to have to follow a more lengthy permitting process. But under emergency procedures, I can put it back the way it was. So we had some challenges, and that's why it took us a long time to get this built back. And more of the same. I think these are just spectacular pictures. Maybe more so because I was actually out there on some of these. So, Hurricane Katrina, wind just blew those cars over. Now they were empties. I can't say a hopper car like that weighs 100 tons. I don't know that hurricane force winds would tip those over, but in this case, those were empties. And tornadoes will do the same thing. We've had cars in the Midwest just blown off of bridges, and you just have to go in and recover them, transfer the product if necessary to get the car back on the rail. This is a different kind of situation. Unfortunately, this was not Mother Nature that caused this. This was unfortunately set by a trespasser. I also experienced this firsthand. This bridge these spans, there was a 1/4 mile worth of timber spans approaching the Sacramento River in Sacramento, California. The main span of the bridge is a movable bridge, but this went to complete cinders in less than 12 hours. Just gone. And from an environmental perspective, this was really challenging because of our proximity to the Sacramento River. We had to contain all the runoff from the firefighting. They used retardant, used a variety of things, and we basically, and it laid itself out pretty nice. We had some nice ditches either side of this that we were able to put some underflow dams in and recover the water. But a very challenging project from a environmental perspective. That's what it looked like before the fire. And that's what it looked like while we were building it back. We were running trains. This was a double-track bridge. We ran the first train, it was 12 days after the fire was out. We work, the thing about railroads and being around for 150 years, we know how to fix our problems, And it was a spectacular project. The regulatory agencies were pleased. We were bringing in concrete spans from just about everywhere. We've tried to standardize on our bridge materials, and they're pretty much steel pipe piles and concrete caps and precast bridge sections. So we've standardized to a certain degree, and just in case something like this happens. But you usually don't have an inventory of a quarter mile worth of bridge laying around. But we were able to get it built back. Another unfortunate situation with a bridge that was vandalized out in the Yuma, Arizona. It's amazing how quick that can burn and spread. The interesting thing about this project, of course, it's a dry wash. You can see there's not any flow, and you get out in that area and you have your monsoons that occur. But we were able to work with the regulators, and we filled that temporarily and put our railroad back in service, and then built the bridge parallel to the existing track. So we were able to restore operations, build the bridge before the rainy season came, and we removed all the fill and put it back the way it was. So some of those issues, how you stage these things, do create some challenges from time to time. But more flooding, when you build your tracks next to rivers, gee, sometimes you're going to have a flood and it's just going to cause you some challenges. But yeah, this is the Cedar River back in Iowa, my home state, and this was 2008. Just look at the homes that built up against that bridge. That's a movable span bridge, and just horrific damage. And then I'll kind of get through these real quick. This was earlier last year, down in the southeast. Just more flooding, more flooding. This one's kind of cool. This is look how long that bridge is, and just how the water's kind of rippling through there. Now this is going to be kind of interesting. This is back near our corporate headquarters in Omaha. Again, Missouri River. This was last spring and summer, and we were able to anticipate this to some degree, because the water was coming down from South Dakota, North Dakota. And then again, track is pretty easy to move around. And just to kind of give you a little lay of the land here, Interstate 29 is to the right, and our Omaha sub is to the next of it there. We raised the track. We had a pretty good idea what the flood levels were going to peak at, and in advance of the floodwaters affecting us, we went out and raised the track. Bring in ballast in rail cars and dump it and surface it and raise it. When you get to a road crossing, you got a little bit of a challenge, because that's a fixed point, when you go through and you've got a road surface. So, but you can pop the crossing panels out and raise it up. So that's how we kind of anticipated, and we kept that subdivision in service. Now I'll kind of close with something a little bit closer to home. Talking a lot about floods, that's probably our biggest challenge. But we do operate in the mountains, and this is down near Oak Ridge in Oregon. And this mudslide was, 2008, and the side of the mountain just came down and knocked us out. And when you get into a mountain grade, you do a lot of switching back, to be able to minimize the grade so you can get up and over the mountain. So we got knocked out in 2 places with this particular slide. 105 days it took us to restore this. And again, we were detouring on some of the other track that we have in the area. But quite a challenge. Now, I'm going to read this just because it kind of frames how big a deal this was. 105 days, 19 million cubic feet of mud came down on top of us. 200 workers, 150 pieces of equipment. We recovered enough timber from trees to build 66 houses, brought in 700,000 tons of rock, 1 million tons of material removed, 30 work trains a day hauled the material, and then what I like to say is, and then 0. That was the number of hotel rooms left in Oak Ridge when our crews came in to work on this. So that being said, I'll open this up to any questions. Anything that pops into your head, I'll do my best to answer. Yes, sir.
And remember to use, oh, you don't have one.
Actually, I'm not a student.
Yeah. Oh.
I'd be curious. Okay, now I'll ask the question. To know a little bit about what you're doing in terms of mitigation and preparation in advance of disasters, and especially here in the Northwest, of course, we're nearing the anniversary of the Tohoku quake in Japan, and there's the concern of a Cascadia subduction zone quake here. So, both in terms of seismic preparation, but maybe other mitigation as well.
And it's when John first contacted me, I put a lot of thought and talked to a lot of people about just what you asked, and really what we monitor for is pretty simple. I mean, again, we've got a good experience with locations where we have problems from rock slides, floods, things of that nature. So we have what are called slide detection fences, and it's not rocket science. It's the equivalent of just a fence along the tracks in areas where we experience boulders. It's got a small current running through it. Boulder rolls down the hill, breaks it. It's integrated into our signal systems. The trains stop. High water detectors, again, probably nothing too complex, but in areas where we're prone to flooding, we can put in high water detectors, and again, that gets integrated into our signal system, so it'll warn an advancing train. More of what we probably look into are things, and what we monitor are things associated with running the railroad. Monitoring our rolling stock to make sure there's, we have a technology now, it's called a wheel impact load detector that's looking for flat spots on the wheel. Because as the wheel's going around, it can gouge your rail, it can degrade your infrastructure. We're doing a lot of things with infrared now, looking for heat buildup, because a lot of these cars have roller bearings, and if you get enough heat in it, you can burn off a bearing, you can have a derailment. Dragging brakes, because every car, every wheel's got a brake. If that's dragging for some reason, you can get a buildup, you can get heat, and then you can get something to potentially derail. A lot of research and money goes into things monitoring the actual track structure and the rolling stock. And beyond that, it's we pretty much know where we've had problems in the past. And we just kind of learn to live with it. But, so hopefully that gives you a little flavor for how we deal with this stuff. Deb.
Let me just follow up on that question a little bit. If we did have the big subduction quake, would the railroad be someone we can rely on, like after the San Francisco quake? Are you guys thinking, how are you going to service different sectors of the Pacific Northwest if the whole thing goes?
Well, and we get asked, and actually we get asked that quite a bit, and probably because of some of these concerns about earthquakes. But to the extent that we can operate, or detour around, I mean, our first priority is going to be getting the railroad back in service. And then it becomes a challenge because you'll get planning entities that are wanting to see about moving materials or equipment, themselves to get the highways restored or the power grid or something along those lines. And we'll help out to the extent possible, but the challenge is sometimes getting that stuff to the tracks and off the tracks to where you need it. But some of these big natural disasters, you're out of business. And for us, we try and maintain inventories of track panels, which are pre-made 39-foot sections of track. So if you've got, if you've lost some railroad, you bring it in and you build it in sections. You try and recover what usable material you can if you've got a washout. And then we've got our own quarries, and we've got cars staged across the railroad with ballast and aggregate in it. So we try to be kind of self-sustaining, which is good because we're all going to, beyond that, we'd all be trying to, draw on the same resources. So it's a tough, really tough question for me to answer, but, we want to help out as best we can, but again, it just depends on how bad it is and whether we can even run our railroad. So, yes?
I was wondering about after you have a bridge that's taken out by a flood and you're reconstructing it, if you consider reconstructing it to a higher level to take into account for floods happening in the future, and also if you have any sort of regulatory hurdles with doing that.
And again, the challenges are, from a regulatory perspective, we always want to get the regulatory agencies involved. And again, if I'm putting it back the way it was, that's less of an issue, but you have to have that dialogue. Now, today, things are so much, most of our bridges are 100 years old or more. You come back with a new pier now, it's going to have less cross-sectional area, than maybe some big concrete footing that existed back then. So in a lot of cases, we're reducing our cross-sectional area across the river. Maybe we can come in with longer spans. So again, we're minimizing that footprint in there. But we work real close with the regulatory agencies, and the Corps and the different DEQs. But if we, when you're in there restoring that, we're always thinking about, or trying to think about the future, because again, with some of this aging infrastructure, if you are going to go rebuild it, to the extent possible, let's build it for the next 150 years. And if we have had problems with debris buildup, maybe we can come in with a lower cross section with our girders and our beams, and maybe fewer piers in the water. But the short answer is, you bet we try and take all that into consideration when we come in here, because it costs a lot of money to put it back. So, but we're trying to really be proactive with the regulatory agencies. And maybe that, historically, maybe we didn't have that good a relationship or weren't as proactive, but we really are wanting to be involved and work cooperatively on restoring our operations. So, yes, sir.
Yeah, I guess I was just wondering maybe what is on the top few of the list of like efficiencies or maybe greening, or what you're trying to do with your infrastructure currently, that's not ones that have been destroyed, but just ways of, bringing them up, if you will.
Sure. And actually, I think the way we're looking to improve our efficiency, and that's a great question, because we're limited in what we can do because we only own so much right-of-way. And again, because of the cost of infrastructure, we're trying to make sure that every train has the maximum number of cars on it, not unlike what a trucking business would do. Let's make sure that we're taking full advantage of the capacity. So do we have the right number of cars on the train? We are doing something new. Now, it's not real new, but the last couple of years, we've been doing something with our locomotives called distributed power. And back in the day, you'd see a locomotive on the front of the train, and then you'd see a caboose go by. Well, the caboose was there for a couple of reasons. To monitor how much air pressure was in your brakes in the last car of the train, because brakes on a train are operated by air. So you needed a physical person in the caboose to read the air gauge, because we didn't have all the different advancements that we have today. And then the other thing is that when they were moving, they would be looking forward to see if there was any dust or sparks or anything. So they're inspecting the train as it's going around curves, and they're watching the air pressure. Well, 15, 20 years ago, we came up with some technology that replaced the caboose. You'll see it when it goes by. It's a little red flashing device, a little antenna on it, and that measures air pressure. Can tell if the last car of the train is moving, so it's all together. But DPU will place additional locomotives in the train itself. It may be on the end of the train, It may be in the middle, 1/3, 2/3, depends on tonnage and the grade of the subdivision it's operating over. And you're all technical folks. The goal is to normalize the forces in those drawbars. Every car is coupled together with a drawbar. And when you're going up and down and around, your forces build up in your train. And they can build up to a point where you could break the drawbar. And once you've done that, the train comes to a stop. You know, your corridor is not moving anything else. You're kind of out of business. So it's, you know, something that we really try and focus on. So the DPU, the front end's pulling. The other units are tied together electronically with computers and such. And it basically just keeps that train, the forces in it, just normalized. And it's just moving along consistent, more fuel efficient, you know, less wear and tear. And we're actually moving more tonnage with less locomotives because of it. And then there's a new technology called positive train control. It's different opinions about what it's going to do for the industry, but it's GPS-based technology that'll make our dispatching more efficient. It'll make our work crews will know exactly where a train is, so that we can maximize our maintenance windows. So we're kind of behind the curve a little bit, you know, historically with technology, but there's some pretty cool things we're doing. And then again, things that focus on ways to minimize the impact and wear and tear on your infrastructure and on your rolling stock, because it just costs so much money to build track. I know I keep repeating that, but it's true. It's just so expensive. Yes, sir.
You showed a couple slides about the capacity that you'll be reaching by about 2035. I was kind of curious about the relationship that capacity has with, I guess, Amtrak using some of the right-of-ways. What are some of the efforts to make sure that those trains run as well?
Well, the thing about passenger, and that's, you know, when we talked about when gas got expensive, there was a renewed interest in really in passenger. You have, maybe my opinion, my expert opinion, you have to have a viable freight network to have a viable passenger network. In this day and age, think about, and I know we're trying it in some states, to go out and start from scratch, the billions of dollars to obtain right-of-way, a contiguous right-of-way, you know, to go out and build a high-speed or a higher-speed network. It's a huge financial drain. So you need to have a viable freight network. And so, for example, between here and Eugene, there's a lot of interest right now in the existing Cascade service. And, you know, what can we do to get the reliability up? Can we add some additional train starts each day? And it'll always be a conversation between the freight railroad and the passenger, because we move freight. That's our business. The money that we receive from the passenger service in the form of, you know, them using our right-of-way pales by comparison to what it takes to maintain that railroad for freight. So when we're out there adding to the network, we are indirectly improving passenger. But it's a challenge. What we say is we'll have the discussion, but at the end of the day, our core business is moving freight. But as we go forward, you know, we just have to be able to make sure we can serve our customers, and if there's an opportunity for increased passenger or new passenger, we're willing to sit down and look at it. But it's going to take public dollars to make it happen. So, just.
I have 2 questions. One, is there any estimates on the loss of revenue that a given corridor is down per day to Union Pacific? So, you know, given that you can't use that corridor. And then that going into, you know, you've shown the vulnerabilities or showing the impacts from the current weather system. As you think in the future, particularly with climate change and how to assess vulnerabilities to the system, what has Union Pacific done on that aspect?
Well, I think, well, let's see. The first question, I'm sure that there is a number. I don't know what it is, but we're not any different than someone like a fiber optics line, that would say, if I'm out for an hour, I'm losing, X number of dollars. But we'll utilize whatever redundancy we can to make sure that we continue to move freight. And yeah, there's going to be a cost if it's out of service, but every corridor, depending on what's the capacity and what is moving through there, is probably going to be different. But when we have a service interruption, restoring those operations, I'm going to emphasize, safely and quickly as possible is our first priority. It's that slide in Southern Oregon, 5 minutes after that was called in, if it even took that long, we were mobilizing to get out there, and we don't hesitate. We get out, we got to get the railroad going, because it's the lifeblood of the economy. Now, what are we doing about areas where we've got prone to, historically maybe prone to problems? I mean, it's going to be having relationships with other railroads to probably detour, because building that redundancy in, you got to look at the return, of doing it. It's kind of a tough one to deal with, because it's just, if you don't have the additional right-of-way to build a redundant system on, it's a real challenge. So we're pretty much limited to what we own, and we're just going to maximize what we have. So I may not have done a very good job answering that question, but when a line's out of service, it's a big deal. I can say that.
I'm just wondering, when I was about 16, I was stopped in a small town in Northern California that a train ran through, but there was no stop there. And I'm sure it wasn't a Union Pacific train, but there was a car that got a flat tire and rolled onto the track, and they weren't able to get it off the track before the train came, because I think the train was, I don't know how fast it was traveling, it seemed like maybe about 70 or 80 miles an hour, and just smashed through the car. And then also, so I'm kind of wondering about how you manage the interface between rail and balancing efficiency versus public safety, and then also other issues of nuisance like noise. I know there's been like an issue down by Union Station about the noise too. So can you talk a little bit about that?
Sure. First off, a train moving at that speed, 100 cars, 100 tons each, take a mile and a half or 2 miles to stop. It really comes down to the public needing to be aware of where they're at and what they're doing. And there's programs like Operation Lifesaver that go out to schools and things of that nature. But these engineers, you just can't stop on a dime, and that's a problem. So, where the public and the railroad come together, at grade crossings. We would love to eliminate grade crossings. And it's for the benefit of both of us, But where you've got them, there's appropriate signal systems and gates and devices that all go into that. We are required by law to sound the horn no less than 15 seconds, no more than 20, in advance of every grade crossing. Now, I say it in advance, so the minute the nose of my locomotive hits here, that's advance. And then I hold my horn until the whole crossing is occupied, and then I let it off. Now, the interesting thing that we have is that urban growth has occurred, and more streets and street crossings have been added, since back in the day. You get into some towns where you got a grade crossing every 150 feet, maybe it's more than that, but you get multiple grade crossings in close proximity. It's 15 to 20 seconds, so depending on how fast I'm going, I may not even be off the first one, and I'm already sounding for this one, and then I'm sounding for this one, and it just sounds like you're just sounding the horn constantly. Now, it is a federal law. The way to eliminate it is through the implementation of a quiet zone And they've done that down here, the city of Portland. It's the road authority's responsibility to initiate it. It's a public road. It's there for public benefit. You go in and you do a little diagnostic, how many vehicles use the road, how many trains use the road. What do I have here today? If I've got just cross bucks, we remember these things, on the county roads. You may have to put in gates. You may have to put in quad gates, and you may have to put in quad gates and islands, because at the end of the day, you don't want anybody to be able to go around those gates and snake through that crossing. So once you get those improvements in place, and it's not without cost, the engineer will not be required under normal circumstances to sound the horn. If someone gets in front of you, and there's other times when we sound the horn when we have our own workmen on or near the tracks, but it is a challenge as we go forward. I was in anticipation of coming and talk today. I was thinking about some of the things that might be asked, and our right-of-way is typically 100 feet wide. 32,000 miles of 100-foot right-of-way. It gets wider in cities, but we can't control what happens outside that 100 feet. So as public policy changes what used to be a light industrial or industrial to condos or things of that nature, it's all of a sudden, where'd that railroad come from? And I will tell you how many times I get that call. I didn't know you were there.
So we're almost done, but we have several good questions from our web viewers. We're not going to be able to get to them all, but I'll put one of them out there that relates to some previous seminars. So we've had a couple speakers this term that have focused on air quality and particularly emissions from diesel engines. And so you've talked about the fuel efficiency of your fleet. Can you talk a little bit about what you're doing in terms of emissions from the diesel engines?
Sure. First of all, the exhaust from a locomotive is regulated by EPA. There are tiers of standards that apply based on the age of the locomotive. When this tiering structure first started, they had was a Tier 0 locomotive, which was of a certain age, and then the new standard was a Tier 1. So the onus is on the locomotive manufacturer to meet that standard. The onus is on me when I buy a new locomotive to buy the current standard. We're currently in Tier 3s locomotives, so any new locomotive UP buys has to be a Tier 3 locomotive. And so they're getting cleaner with every iteration of the new tiering. There's lower sulfur fuels. Typically, the issue with diesel is the particulate matter, and it comes from sulfur. And so there's lower sulfur fuels. EPA has got standards now that are kicking in for use of lower sulfur fuels. And in regions like California, Texas, Chicago, where they have documented poor air quality, and where they want to advance what we're doing, because we're complying with what's required. We're using the proper tier, we're using the appropriate diesel fuel. But when we get into areas that have poor air quality that want to try and advance things, we've got some pretty neat technologies that particulate filters. We have a locomotive called a genset. And actually, if you go to our external website, up.com, a lot of this information is out there. But these gensets are over-the-road truck engines. So they're very clean, and it's not like the engine that's in our our locomotives. So now the displacement on one of those cylinders is like the equivalent of the displacement of an over-the-road truck. So again, we're trying to reduce our carbon footprint, which equates to reducing emissions, which equates to reducing greenhouse gases and particulate. Most of the onus is on the locomotive manufacturers, but in certain regions, we work with the air districts to see if we can do some things to help advance those things faster.
Well, thank you. We are up at our 1 o'clock time.
I never thought I could go an hour, but you're welcome. Thanks.